Students, today let us discuss about an important chapter in three-dimensional geometry is direction cosines and ratios. Let us consider origin, y-axis, this is z-axis, this is x-axis. You take a one line, this line is OP, which makes an angle alpha with the positive direction of x-axis. It's a beta with the positive direction of what? X-axis. This is gamma. If alpha, beta and gamma be the angles made by the line OP with the x-axis, with the y-axis and z-axis, then cos alpha, cos beta and cos gamma are known as a DCS of a line OP bar. Means alpha, beta, gamma are the angles made by the line with the positive direction of x-axis. If I measure those angles in terms of the cosine of the functions, we call it as what? Direction cosines. So therefore, now I take cos alpha, cos beta, cos gamma are known as DCS of a line. So I can also call it as this cos alpha as L, cos beta as M, cos gamma is equal to N. I can write DCS of OP bar. OP bar indicates it is in positive direction, that is LMN. So if I want to measure the direction cosines of PO bar, that is in negative direction. So therefore, I can write the DCS of PO bar. I can write this one as cos of pi minus alpha, cos of pi minus beta, cos of pi minus gamma. I can write them as minus cos alpha, minus cos beta, minus cos gamma. Therefore, I can write minus L, minus M, minus N. For a line, it has directions, it's in two ways. One is in positive direction, other one is what? Negative direction. On the whole, the DCS of a line are plus or minus L, plus or minus M, plus or minus N. But we focus attention only on what? Positive direction. So therefore, let alpha, beta and gamma be the angles made by the line OP bar with the positive direction of x-axis. Then cos alpha, cos beta and cos gamma are known as DCS of a line in the positive direction. Similarly, when alpha and beta and gamma are the what angle made by the line with what x and y and z axis in the negative direction, PO bar, the DCS of PO bar, it makes an angle pi minus alpha with x-axis, pi minus beta with y-axis, pi minus gamma with z-axis. If I measure in terms of cosine of the functions, we call it as cos of pi minus alpha. This is nothing but minus cos alpha, minus cos beta, minus gamma. So therefore, minus L, minus M, minus N are also DCS of a line. So therefore, hereafter, so every line has two ways of representing the direction cosines, plus or minus L, plus or minus M, plus or minus N. Okay, right. After knowing the definition of direction cosines, if we take LMN or the DCS of a line, before that L is equal to cos alpha. Before that it's an alpha. alpha comma beta comma gamma be the angles made by the line with the positive direction of x-axis. They must always lie between what? 0 and pi. So therefore 0 less than alpha, less than beta, less than gamma up to pi. They must belongs to 0 to pi. Every such angles we call it as what? Direction cosines. Now coming to, you can take this one as equal to also. Okay, equal to also. So therefore now coming this one is, I want to find out, that is a direction cosines of x-axis. This is y-axis, this is z-axis, this is the origin. Now what is cos alpha, cos beta, cos gamma? A line making an angle with the positive direction of x-axis, y-axis and z-axis. Now I am taking the line as x-axis. So therefore, when the line is x-axis, now when the line is y-axis, line is z-axis, the angle made by the line x-axis with x-axis is 0 degrees. With y-axis, pi by 2. With z-axis, pi by 2. So therefore, let us see now DCS of, I can write DCS of OP bar, I wrote it as cos alpha, cos beta, cos gamma. So now I can write now DCS of x-axis. So angle made by x-axis with x-axis is cos 0. Angle made by x-axis with y-axis cos pi by 2. Angle made by x-axis with z-axis pi by 2. So therefore I can write 1, 0, 0 or the DCS of a line. Next I can write DCS of y-axis. DCS of y-axis. I can write angle made by y-axis with y-axis 0, with x-axis pi by 2, with z-axis pi by 2. Therefore pi by 2. Next cos 0, this is cos pi by 2. Nevertheless, it's a 0, 1, 0. Next, the DCS of z-axis, the DCS of z-axis, z-axis makes an angle 0 with z-axis, with x-axis pi by 2, with y-axis pi by 2. So therefore, I can write pi by 2, it's a pi by 2, it's a cos 0. I can write this one as 0, it's a 0, it's a 1. Remember, the direction cosines of x-axis are 1, 0, 0. Direction cosines of y-axis 0, 1, 0. Direction cosines of z-axis 0, 0, 1. Followed? Now look here. Here on direction cosines, we come across about 2 points. Provided if alpha and beta and gamma are the angles made by the line with the positive direction of x-axis, first of all, alpha, beta, gamma, each angle must lie between 0 and to what? Pi. 0 to pi. Close interval 0 to pi. Alpha must belongs to 0 to pi. Beta must belongs to 0 to pi. Gamma must belongs to what? 0 to pi. Every such angles later we can define as what? Direction cosines. The next comes about, so whenever direction cosines are given, we want to express the point in terms of direction cosines. After knowing the definition of direction cosines, the third note is, if OP is a directed line segment with DCS L, M, N and OP is equal to R, then the coordinates of P are LR, MR, NR. Let us take, this is y-axis, this is z-axis, this is x-axis, this is the origin. You take a line P of x, y, z is a point defined in a space. So therefore, draw a line from P to the y-axis. Let it meet at L. Let it meet at L. And yes, given the length of OP is equal to R, take this as R. No doubt, this is nothing but Y. No doubt, it's a what? Y. Let it, this line makes an angle beta with the positive direction of y-axis. Now, with reference to the y-axis, we are finding the same treatment, same argument can also be extended for z and x-axis respectively in the same fashion. So therefore, now OP is equal to R and the coordinates of P are x, y, z, and this is y, the distance from this one, because you are on y-axis. From a right angle triangle, the proof of this one is from right angled triangle, OPL, given OP is equal to R, OL is equal to Y. OL is equal to Y. So therefore, I can write what is cos beta. Cos beta is equal to OL by OP, it's equal to Y by R. So therefore, I can write cos beta is equal to Y by R. Meanwhile, I can write Y is equal to, that is R into cos beta, where cos beta is nothing but M. Why? Cos alpha is equal to L, cos beta is equal to M, cos gamma is equal to N. In place of cos beta, I could write as M. So therefore, now we have expressed the y coordinate of the point as MR. Let P of x, y, z be a point in the space. If you consider that point as x, y, z, I got y as R, M. Similarly, I can also go for cos alpha is equal to x by R and cos gamma is equal to z by R. The students must have a good perception in thinking about x-axis, about z-axis in construction of a triangle. It would be tedious to represent three-dimensional. So therefore, now cos alpha is equal to x by R. Write down this as L is equal to x by R and N is equal to z by R, where cos alpha is equal to L, cos beta is equal to M, cos gamma is equal to N, correct? So therefore, x is equal to LR and z is equal to NR. So therefore, I can write P of x, y, z is equal to LR, MR, NR. P of x, y, z is equal to LR, MR, NR. Hereafter, when the line makes an angle alpha, beta, gamma with the positive direction of x-axis, when the line segment length is given to be R, then that point P can also be expressed in terms of direction cosine into its magnitude of a line. That is, a LR, a MR, and what? NR. So therefore, P of x, y, z is equal to LR, MR, NR. Yes. Note 4. If OP is equal to R and P of x, y, z be the point, then DCS of OP bar in the previous figure is given to be x by R, y by R, z by R. We can also call it as what? L, M, N, where L is equal to x by R and M is equal to y by R, N is equal to what? Z by R. So therefore, L is equal to x by R, x equal to LR, M is equal to what? NR, and Z is equal to what? NR. This is how you can express the coordinates of a point. When the coordinates are given, the length of the segment OP is given, you can write every point in terms of direction cosines, and also the direction cosines of line segment can also be found as such: x by r, y by r, z by r. Now, the relation between DCS of a line In the previous figure, we come across it already. This is x, that is y-axis, z-axis, x-axis. This is a line OP. This makes an angle alpha. This makes an angle beta. And this makes an what? Gamma. Now, if I take this point as x, y, z, and the length of this is what? R. Take this one. The statement is, if L, M, N are the DCS of a line, then L square plus M square plus N square is equal to 1. We have to prove that. Let us see how it is. Let O be the origin, and P of x, y, z be a point in space, and alpha, beta and gamma are the DCS of a line, or else angle are the angles made by the line with positive direction of x, y and z axis respectively. Then from a right angled triangle OPL, you can go for it. This is y. From right angle triangle OPL, cos beta is equal to y by r. L is equal to y by r, right? That is, M is equal to y by r. Similarly, I can also find out cos alpha is equal to x by r, cos gamma is equal to z by r, which implies that is L is equal to x by r, N is equal to z by r. Now I am going to write L square plus M square plus N square is equal to, substitute the corresponding values, x square by r square plus y square by r square, next z square by r square. Now I can write this is x square plus y square plus z square by r square. We know already the distance between the 2 points in three-dimensional approach as, if I take this point P as x1, y1, z1, a q of x2, y2, z2, the distance between the 2 points PQ can be defined as a square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Instead of x2, y2 and x1, y1, I can take this point as 0, 0, 0 and this as x, y, z. I can write OP square is equal to x minus 0 whole square, y minus 0 whole square, z minus 0 whole square, okay, square root. Now if you're squaring on both sides, it comes as OP square, but OP is nothing but r x square plus y z square. So therefore, this also r square, this also r square, get cancels. L square plus m square plus n square, r square by r square, 1. Yes, we have proved the sum of the squares of the direction cosines of a line is equal to 1. That is, L square plus m square plus n square is equal to 1. That is, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Followed? Now when you know the cos square alpha, we can also express in terms of sin alpha. We can also express in terms of cos 2 alpha. Let us see. Now we have proved L square plus m square plus n square is equal to 1. Followed? I can write this one as cos square alpha, cos square beta, cos square gamma is equal to 1, right? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now, why L is a cos alpha, m is a cos beta, n is a cos gamma. Now, when you know this, I can also write 1 minus sin square alpha, 1 minus sin square beta, 1 minus sin square gamma is equal to 1. I can write this one as sin square alpha, sin square beta, sin square gamma. If you transfer that side, it will be a 2. Right? So therefore, now we got sigma cos square alpha is equal to 1, sigma sin square alpha is equal to 1. Right? Now, I can also write in terms of, that is 1 minus cos 2 alpha by 2, 1 minus cos 2 beta by 2, 1 minus cos 2 gamma by 2 is equal to how much? 2. 1 minus cos 2 alpha is nothing but a 2 sin square alpha. 2 to get cancels. We have arrived at these conditions. So therefore, transfer that side. Therefore, 3 minus sigma cos 2 alpha is equal to 4. Transfer that side. Therefore, sigma cos 2 alpha is equal to how much? Yes, 1. Means hereafter cos 2 alpha, cos 2 beta, cos 2 gamma is equal to how much? 1. Correct? So therefore, with these direct questions, we have arrived at many more results. One among them, important one, vital one, is L square plus m square plus n square is equal to 1. This is a vital result. It plays a key role in defining some more relations as a decide. So therefore, now cos square alpha plus cos square beta plus cos square gamma is equal to 1. Therefore, sigma cos square alpha is equal to 1. So therefore, 1 minus sin square alpha, 1 minus sin square beta, 1 minus sin square gamma is equal to 1. So therefore, I can write sigma sin square alpha is equal to 2. Sigma sin square alpha is equal to sin square alpha plus sin square beta plus sin square gamma is equal to, therefore is equal to 2. Right? Followed. Sin square alpha can also be expressed in another form as, that is 1 minus cos 2 alpha by 2, 1 minus cos 2 beta by 2, 1 minus cos 2 gamma by 2 is equal to 2. Therefore, 3 minus 1, 1, 1, 3. You transfer 2 to this side, it becomes 4. So therefore, 3 minus cos 2 alpha, sigma cos 2 alpha is equal to what? 1. So therefore, cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 1. Followed? Now let us recall the definitions of relation between the direction cosines of a line. If a line makes an angles of 45 degrees with x and y axis, then the angle made by the line with z-axis is dash. Let us see what's the solution of this one is. Now he has given alpha and beta is equal to 45. He is asking gamma is equal to question mark. We have the relation cos square alpha, cos square beta, cos square gamma is equal to 1, or else you can go for sin square alpha plus sin square beta plus sin square gamma is equal to 2. So you can make use of any relations also. Sigma cos 2 alpha is equal to 1 also you can go for it. So therefore, now alpha is equal to cos square 45. This is cos square 45 plus cos square gamma is equal to 1. This is cos 45 is 1 by root 2. 1 by root 2 whole square, it's a f. Is equal to cos square gamma is equal to 1. So therefore, cos square gamma is equal to 0. Therefore, cos gamma is equal to 0. Therefore, gamma is equal to how much? 90 degrees. Therefore, when x and y axis are making an angle 45 with x and y axis respectively, then the angle made by the line with the z axis is what? 90 degrees. Let us recall some concepts what we have discussed earlier. If OP is equal to 13, DRS of OP bar are 6, 8, minus 24. Then if I go for DCS also you can go for this. Okay, DCS of OP bar are 6, 8, minus 24. Then P is equal to dash. We have the what? Now P is equal to P of x, y, z can also be written as LR. It's a MR, NR. What is OP? OP is equal to R is equal to 13 and L, M, N is equal to 6, 8, minus 24. Just you substitute P of x, y, z is equal to LR 6 into 13, next 8 into 13, next minus 24 into 13. This is how you can find out when DCS of a line is given, and the length of the line segment is also given, you can express in this form. Followed. The next result is on the relation between the direction cosines of a line. Let L, M, N be the DCS of a line, then maximum value of element is dash. When element or the DCS of a line, we have the relation L square plus M square plus N square is equal to 1. In this product element, there are three variables L, M, N. If that product is to be maximum, L must be equal to M must be equal to N. So therefore, if L is equal to M is equal to N, treat this as a one result. So therefore, 1 implies 3L square is equal to 1, which implies L is equal to plus or minus 1 by 3. Plus indicates you are in positive direction, minus indicates negative direction. But we are always tend to discuss in what positive direction. So therefore, I can track L is equal to 1 by root 3 since M is equal to L is equal to N. So therefore, I can also write L is equal to M is equal to N is equal to 1 by root 3. I want to find out the maximum value of element. Therefore, this becomes 1 by root 3. It's a root 3. It's a root 3. Therefore, this becomes 1 by 3 root. So, therefore, the maximum value of element is 1 by 3 root 3. 1 by 3 root 3. Another result comes in this. Let L, M be the DCS of a line, then maximum value of LM. Earlier in LMN, it was the approach of three-dimensional, where L, M, N. Nevertheless, L is nothing but a cos alpha, M is nothing but a cos beta, N is nothing but a cos gamma, where alpha, beta, gamma are the angles made by the line with the what? Positive direction of x, y and z axis respectively. There we have considered three mutually perpendicular lines. We discussed in space. Now a line has L and M. Certainly the line must be defined in two-dimensional. It's a 2D line. It is quite obvious. Then what is L? L is nothing but a cos alpha. M is nothing but a cos beta. Okay, if L and M are the what? DCS of a line, what about the relation? L square plus M square is equal to 1. Right? So therefore, what is the length? R square is equal to x square plus y square. So therefore, now we know it already. The result of this one is, since L square plus M square is equal to 1. Why? For three-dimensional, L square plus M square plus N square is equal to 1. We have proved as a relation between the DCS of a line. Here also, L square plus M square is equal to 1. If this product is to be maximum, there L and M they must be equal. L is equal to M. L is equal to M. So therefore, which implies, you call it as 1. So therefore, which implies 2L square is equal to 1. So therefore, L is equal to plus or minus 1 by root 2. Since we consider in the positive direction, I took 1 by root 2. So now since L is equal to M, I can write this as 1 by root 2. So therefore, LMN is 1 by root 2, 1 by root 2. It's F. Therefore, the maximum value of LMN is 1 by 2. Now, the another result is, if L, M, N are the DCS of a line, then maximum value of LM plus MN plus NL is dash. Look, for this one is, now I go by, we know that AM is always greater than or equal to GM is greater than or equal to HM in progressions. But for this context, I take only AM is greater than or equal to GM. AM is greater than or equal to GM. Let L, M, N be the DCS of a line. Then L square plus M square by 2 is greater than or equal to L square M square. They are also DCS. So therefore, by using AM is greater than or equal to GM, I took, instead of taking for L and M, I took for what? L square and M square. So therefore, now this is nothing but L square plus M square is equal to 2LM. Next, M square plus N square by 2 is greater than or equal to N whole square is same as M square N square. It makes no difference. Which implies M square plus N square is greater than or equal to 2MN. Next, N square plus L square by 2 is greater than or equal to NL whole square or N square L square is same as, that is N square plus L square is greater than or equal to 2NL. add all the three results. We get as 2 times of L square plus M square plus N square is greater than or equal to 2 into Lm plus Mn plus NL. This 2 goes. We know already the relation between the direction cosines of a line as L square plus M square plus N square is equal to 1. Therefore, this value becomes 1 is greater than or equal to, that is Lm plus Mn plus NL. Therefore, I can write this in the form of Lm plus Mn plus NL is less than or equal to 1. So, therefore, the maximum value of Lm, Mn, NL is 1. Followed? So, therefore, hereafter, when Lmn are the DCS of a line, to find the maximum value of Lm plus Mn plus NL, here is the one important identity. M is greater than or equal to Zm. So, by using this, if let L, M, N be the DCS of a line, certainly these are also DCS of a line. L square plus M square by 2 is greater than or equal to square root of L square plus M square. Now you cross multiply, because square root of L square M square is nothing but a Lm. Cross multiply 2, we have 2 Lm. That is M square plus N square is greater than or equal to 2 into Mn. Next, N square plus L square greater than or equal to 2 into NL. Add up, we got the maximum value. Less than means what? Maximum. Greater than means what? Minimum. So, therefore, the maximum value of Lm plus Mn plus NL is 1 only. These are the little discussions, somewhat applications of the direction cosines under the relation between the direction cosines of a line. Let us move to understand the definition of direction ratios. Sir, in particular, what is the difference between direction ratios and direction cosines? Any 3 real numbers, say for example, A, B, C, be 3 real numbers. If you want to prove them, if you want to define them as a direction ratios of a line, provided they must be proportionality with what? Direction cosines. When the direction cosines of a lines are proportional to what? Some real numbers, then those numbers, real numbers, we call it as what? Direction ratios. Let us see. Let L, M, N be the DCS of a line and A, B, C be 3 real numbers. Then when the DCS of L, M, N of a line are proportional to A, B, C, that is L by A, M by B, N by C, then A, B, C are known as DRS of a line. So, therefore, any 3 real numbers are said to be DRS of a line. They must be proportionality with what? Direction cosines. Then every such real numbers we call it as direction ratios. I can write, so therefore, L is equal to AK, M is equal to what? BK, N is equal to what? CK. Some K is a constant of proportionality. So therefore, when L is equal to AK, M is equal to BK, N is equal to CK. So why? They are proportionality with that. So with this concept, let us find out if A, B, C are the DRS of a line, then KA, KB, KC are also DRS of a same line. When A, B, C are the DRS of a line, then A by K, B by K, C by K are also DRS of a line. So therefore AK belongs to R. So therefore, when ABC are the DRS of a line, then KA, KB, KC or A by K, B by K, C by K are also DRS of a line. Let us move to understand how to find out a DCS of a line when DRS of a line are given as such A, B, C. We shall see. When A, B, C, I start. Let A, B, C be the DRS of a line, then DCS of a line is equal to A by square root of A square plus B square, plus or minus also you can write B by square root of A square plus B square plus C square plus C square. Okay, next C by square root of A square plus B square plus C square with plus or minus, plus or minus, plus or minus, plus or minus. DCS may be in positive direction, may be in the negative direction. Followed? So therefore, now what I do is A by this, B by this, C by this. So now I can write the proof of this one is let A, B, C be the DRS of a line, which implies L by A is equal to M by B is equal to N by C. Now where L, M, N are DCS of a same line, which implies L is equal to AK, that is M is equal to BK, N is equal to CK. We know that, since L square plus M square plus N square is equal to 1, so therefore AK whole square, BK whole square, CK whole square is equal to 1. So therefore K square into A square plus B square plus C square is equal to 1. Therefore K is equal to plus or minus square root of A square plus B square plus C square. Right? Now DRS of a line, DRS of a line, I can write DRS of a line is equal to A, B, C. I want DCS of a line. DCS of a line is equal to, yes, that is, what is that? AK. Now I can write plus or minus AK, BK, CK, Y, LMN. So therefore, I can write this as plus or minus, what is your AK? K is nothing but square root of A square plus B square plus C square. B by square root of A square plus B square plus C square. C by square root of A square plus B square plus C square. This is how you can establish a relation between the DCS and the DRS of a line when they are given in terms of ABC. When ABC or a DRS of a line, then their codirection cosines are given by plus or minus A by square root of a square plus b square plus c square, b by square root of a square plus b square plus c square, c by square root of a square plus b square plus c square. Let us see. Now here a, b, c be the what? Diagonals of a line, and when they are diagonals of a line, they must be proportional with what direction? Cosines. Any real numbers are said to be what? Diagonals of a line. The first and foremost thing they have to satisfy. There must be proportionality with what? Direction cosines. L by A, M by B, N by C, where LMN are DCS of a line. Therefore, L is equal to AK, M is equal to BK, N is equal to CK, K is the constant of proportionality. Now, since L square plus M square plus N square is equal to 1, so now substitute this. Now, therefore, DCS of a line are given to be AK, BK, CK. K is what? 1 by square root of A square plus B square plus C square with plus or minus. We could get in that way. Plus indicates positive direction, minus indicates negative direction. Let us recall this concept, this definition, one or two examples. Yes, let us recall the concept of this. For example, let 6, 2, 3 are the DRS of a line, then DCS of a line or dash. So now let us take this one as A, B, C is equal to 6, 2, 3. They are DRS of a line. Then I can write these are the DRS. Now what is a DCS of a line? The DCS of a line is given by, that is A by plus or minus square root of A square plus B square plus C square, that is B by square root of A square plus B square plus C square by square root of A square plus B square plus C square. You simplify this, plus or minus 6 by square root of 36 plus 4, 40, 49. It's a 49. Yes, come on, 2 by root 49. Yes, the next 3 by root 49. Now this is nothing but plus or minus 6 by 7, 2 by 7, 3 by 7. This is how you can find out the DRS of a line, a DCS of a line, as well as DRS of a line. So therefore, DCS of a line by using what? DRS. From this you can understand DCS of a line is nothing but a DRS of a line. Every DCS of a line is a what? DRS of a line. So therefore, now without a what denominator, it's a DRS. With the denominator is what? DCS of a line. So this is how we can find out DRS and DCS of a line when DRS are given. Means if A, B, C are the DRS of a line, then their corresponding DCS of a line is given by plus or minus A by square root of A square plus B square plus C square, B by square root of A square plus B square plus C square, plus C by square root of A square plus B square plus C square.